Section 5.5, solve absolute value equations. The keyword here is going to be equations. So you're going to see an equal sign. Okay, so let me give you a little example first of what you can expect to see here. I have these little characters here in a number line. So if I were to just kind of take, I don't know if I can do it without my mouse. There we go. Take this little chef here and place her on the number line right there. Where'd she go? Did she disappear? Let me try that. There she is. Okay, and then take this little violinist. Okay, if I were to move him here on the number line. Talking about absolute value, I've got these two characters situated on the number line, and then if I were to stand right here at 0, okay, both the chef and the violinist are the same distance away from me at 0, okay? They're both 4 units. So from the violinist to me is 4 units, and from the chef to me is 4 units. It doesn't necessarily matter that the chef is at -4 and the violinist is at +4. They're both 4 units away from me. So distance is always going to be positive. Just like if we're talking about absolute value, it's always going to be positive because it's talking about something's distance from 0. Okay, so if we're here at -4 or here at +4, we're both 4 units away from 0. Doesn't matter that one's negative or one's positive. So when you're answering absolute value, if I say what's the absolute value of -700, you would say 700 because whatever is there is 700 units away from 0. So if you look at this first example, this x right here, the absolute value of x is 4. So while we're inside those brackets still, we could be talking about +4, which was like the violinist over here. So the absolute value of +4 is +4. Or we could be talking about like the chef, which was situated at -4. So while it's still inside the brackets, it can be negative, okay? Because then when you say what is the absolute value of -4, your answer then is +4. So looking at this next example, x plus 1 equals 4. That x value, while it's inside the brackets, could be a negative number, okay? Because if we were to say -5 plus 1, well, what does that give us? That gives us -4. And what do we know the absolute value of 4 is? I'm sorry, -4? We know it's +4. So that x value could have been -5 because then when it's plugged in, you're going to perform the operation inside those brackets first. So -5 plus 1, we get -4, and then take the absolute value of that to get your answer of +4. The answer also for x also could have been a +3 because 3 plus 1 is 4, and we know the absolute value of +4 is also 4. So x could have been a +3. What you'll notice is that we have 2 different answers for an absolute value equation. Okay, so you'll see that throughout the rest of these notes. The absolute value equation, the absolute value of x plus a equals c, where c is greater than 0, meaning it has to be positive, is equivalent to the compound statement x plus a equals a positive c, or whatever that x plus a is could equal a negative c as well. Okay, so let's look at a few examples. Solve the absolute value equations and check your solutions. So if you notice, we have inside our brackets 6x minus 3 equals 15. So there's going to be some x value that when we plug it in here, we're going to get a -15 and we're going to get a +15 because then when we take the absolute value of those two numbers, we get this 15. Okay, so we have to figure out what those two x values are. So the way that we're going to do that is we're going to take 6x minus 3, set it equal to the positive answer version. Okay, that would be like our violinist over here at +4, and then we're going to take 6x minus 3 and set it equal to a -15. That would have been like our chef over here standing at -4. So we have two separate equations, okay, and you're going to solve them separately to get your two different answers for x. So for the first one, if you add 3 to both sides, you get 18. So 6x equals 18. Divide both sides by 6, and x equals 3. Okay, there's one of your answers. On the other side, add 3, you get negative 12, and then divide by 6, and you get negative 2. Again, it's okay to get a negative answer because what we're going to do is plug in that negative 2 where the x is, and we say 6 times negative 2 minus 3. 6 times negative 2 is negative 12. Negative 12 minus 3 is negative 15. And then taking the absolute value of negative 15 gives us positive 15. So we do get that positive 15. So again, you're going to have two answers for absolute value equations. You can do B on your own. And if we take a look at C, one of the things that you need to do for absolute value equations, listen carefully, is isolate the brackets, okay? We can make that into a little reminder over here. We want to isolate the brackets. They are not parentheses, okay? So you're not distributing. Do not distribute. I can even make that a note. Do not distribute. Okay, they are not parentheses. So what you need to do is get this bracket by itself before you split it up into these two separate equations here, okay? So what we would need to do is undo everything that's being done to the brackets. So we have multiplication by the 7 and we have addition by the 1. So working backwards to get the brackets by itself, we need to subtract 1 from both sides. So we end up getting 7 times the absolute value of x plus 3. And then we're subtracting 1 from both sides, so we get 42. Next, it's 7 times the absolute value of x plus 3. So we're going to undo that by dividing both sides by 7. So then we're just left with the absolute value of x plus 3 equals 6. Now that the brackets are by themselves, we can split it up into two separate equations. We can say that we have the equation x plus 3 that will give us a positive 6, and the x plus 3 that will give us the negative 6. Okay, those are our two equations now that the brackets are isolated. And so then subtract 3 from both sides. Subtract 3. X equals 3. And then if we subtract 3, x equals negative 9. Okay, those are your two answers. And it should seem a lot simpler once the brackets are isolated. That was only a one-step solution right there after we had to isolate. So if we look at example D real quick, again, what you would want to do first is add 1 to both sides. So you get 2 times the absolute value of 6x plus 5 equals 26. And then you would need to divide both sides by 2 because, again, we're trying to isolate the brackets. So we get 6x plus 5 equals 13. Now we can split this up into our two separate equations. Okay, we have the 6x plus 5, that will give us a positive 13, and the 6x plus 5, that will give us the negative 13 inside the brackets. And now you can solve those two equations for x and get your two answers. Moving on, if I go to example F, I've got the absolute value bars isolated, so I'm going to set up my two equations. 2x plus 12 equals a positive 4x, and then a 2x plus 12 equals a negative 4x. And solving for x, if I subtract 2x from both sides, I get 12 equals 2x. Divide both sides by 2, and I get 6 equals x. If I solve the next one, subtract 2x, I get 12 equals negative 6x. Divide both sides by negative 6, and I get negative 2. Okay, so everything seems nice and dandy, right? Well, if we were to plug our answers back into the original equation, okay, I would have the absolute value of 2x. So if I were to plug in 6, my first answer, plus 12 equals, notice that I have a 4 and an x on the right side. So simplifying, I get 12 plus 12, the absolute value of that equals 24. And then I get the absolute value of 24 equals 24, which, yes, it does. And the second one, if I plug in negative 2 for x, 2 times negative 2 plus 12, does that equal 4 times negative 2? Well, I get negative 4 plus 12 equals negative 8. You could stop right there because we're saying the absolute value of something equals a negative number, and that is never, ever going to happen. Even if we say 12 minus 4, which is 8, we end up getting 8 equals negative 8. That is not true, okay? So basically what we see here, this x is actually not a solution to this absolute value equation. Even though it worked with our math here in the first part, when we plugged it back in, it gave us a false answer. So this actually has a special name right there, that next bullet point. When you're solving an absolute value equation, it is possible to have a solution that does not satisfy the original equation. This is called an extraneous solution. Okay, and most likely you'll see that when you have a variable on the right side of your equation as well. Not always, but sometimes. So look out for those as well when you're solving absolute value equations. And the last one, solve and check the absolute value equation. So if you notice here, the first thing we would need to do to isolate the brackets is to subtract 5 from both sides. And we would get 4y minus 6 inside our absolute value brackets equals negative 5. So again, just like over here, you will never, ever take the absolute value of anything and get a negative as your answer. So you can just say right now that there's no solution. Okay, there's nothing that can be plugged in for y to make that true. There are 2 story problems, but I think I'm running out of time on this clip. So look for those in the collaboration space notes when you're finished.